Good morning, children. This is class 11th physics, chapter number 8, motion. We are to the second topic. Let's go through the learning objectives first. So, children, when the class will be over, you will be able to define scalar quantity and vector quantity. Means you will be able to understand the difference between a scalar and a vector quantity. You will be able to define distance, displacement, and differentiate between the two terms. You will be able to name the device which is used to measure the distance. So these are the objectives which you should be able to achieve at the end of the class. So be very attentive, children, right? So let's start with the first topic in this, and that is physical quantity. So children, physical quantity. For example, I ask you what's your mass. You will say, ma'am, my mass is 30 kg, right? Means you measured it on a weighing machine, right? If I ask you what is the length of your science NCRT, ninth science NCRT, you will measure it with a scale and you will tell me, ma'am, it's 15 centimeters. Okay. For example, if I ask you what is the what is the time right now? You will say, ma'am, the time is 11 o'clock, right? That you measured it with the help of the with the help of the clock, right? So all those quantities which you can measure them, either you can measure them directly or it can be indirectly also, right? Indirectly is, for example, pressure. Pressure, we are having pressure gauge to measure it directly. But if you want to find pressure, you can first measure force. You can measure area. You know, pressure is force upon area. Right, beta? So, all the quantities which can be measured directly or indirectly, they are called the physical quantities. And one more thing is there, that all quantities in terms of which the laws of physics can be expressed. The Newton's law, gravitational law, the Coulomb's law, whatever laws are there, in that all laws, these physical quantities are present. So all quantities in terms of which laws of physics can be expressed and which can be measured directly or indirectly are your physical quantities. Let's see the example of physical quantities. Distance, you can measure. Your mass, time right now, the temperature of the room, your speed if you are coming to the school on the Activa, the pressure, the electric current flowing through the wire, through the geyser, through the refrigerator. Weight we have done in class 8. Weight is the gravitational pull, the gravitational force exerted by the earth on you, right? Velocity, quantity of matter, pressure, displacement, force, momentum. These last physical quantities we will be covering in class 9. We will be able to understand them now. So physical quantities are all those quantities which can be measured directly or indirectly, and in terms of them the laws of physics have been expressed, right? So these all are physical quantities. So children, all these physical quantities we can categorize them into two. That is, all the physical quantities, they are either scalar quantity or they are vector quantities. Now what is scalar quantity? So children, scalar quantity, for example, I ask you what is your mass. You will say, ma'am, my mass is 35 kg, right? 35 kg. So your 35 is the number. It is the magnitude. It is the number. It is the magnitude, right? So after that, if I ask you in which direction it is 35 kg, oh, it's a useless question, right? No sense. So to describe mass, you require only the number 35, only magnitude. Direction is not required to describe mass, to describe time, to describe distance and to describe speed and many more quantities. So all those physical quantities which require only magnitude, no direction for its description, they are called scalar quantities, right? So let's read the definition for scalar quantities. Scalar quantities are those physical quantities which require only magnitude, only the number for its complete description. Example, mass, time, distance, speed, and many more. Right? Now let's try to understand the vector quantities. So children, vector quantities, they require both. They require magnitude as well as direction. For example, if I talk about velocity, suppose you are moving in car to some place, suppose Jaipur, right? So you will say, ma'am, I went to Jaipur and our car moved at the speed or at the velocity of 70 kilometer per hour towards Jaipur. So there you are giving me the magnitude, that is 70 kilometers per hour, plus the direction, that is towards Jaipur. So any physical quantity which requires both, it requires both magnitude as well as direction for its description, are your vector quantities. Some of the examples of vector quantities are weight, displacement, and velocity. Weight, you know, weight is the gravitational force exerted by the earth on any object. So earth is always going to pull the object downwards, right? When you jump, you land back on the earth. If you throw a ball in the upward direction, after some time it is going to return down towards the earth. So weight has direction, that is in the downward direction, right? So they all are vector quantities, right, beta? So this was your scalar and vector quantity. Now next, let's move to the next topic, that is distance. So children, distance. Distance is the total path length covered by an object. So children, if you are moving somewhere, if you are doing jogging, you are going to move on a particular path, रास्ता. तो उस रास्ते, जिस रास्ते पे आपने move किया, the path on which you have moved, the length of that path, right? That is the distance. So let's read distance once more. What is distance? Distance is the total path length covered by the object. That is the distance. Right, beta? For example, here in this diagram, an object or an insect is moving from point A to B, which is 5 meters. Then the insect is crawling from point A to B, which is 10 meters. From B to C, 8 meters. And then the insect is moving from point C to D, that is 10 meters. Right, beta? So the insect has moved on this path, that is OA, B, C, D. The insect moved on the path O, A, B, C, D. This is the path on which the insect has moved. Let's calculate the total path length. So children, the total path length will be 5 plus 10 plus 8 plus 10. So the total path length comes out to be 33 meters. That is the total distance traveled by the insect, right, beta? And to describe distance, you don't require direction. So distance is a scalar quantity. And distance, we know it is measured in meter. Right, children? SI unit. SI unit is system international. Is internationally, anywhere in the world, the standard unit of distance is meter. Okay, so distance is the total path length covered by the object. It is a scalar quantity and it is SI unit is meter. Clear? Okay. Children, distance we know, if the object has moved, distance has to be positive. What value of distance are possible? Either if the object has not moved, distance can be 0 or it will have positive value. Distance can never be negative. Distance can never be negative. Distance can be 0 or it can be positive. Right, beta? Okay. Now let's move to the next slide, which tells us about the displacement. Displacement, right? Displacement is a new term for us. See, if it is like place, you all keep on changing your places, right? Whenever the period changes, if it is your class teacher, you be at your place allotted to you. But once the class teacher goes and you are having other teacher coming for the next class, you change your place, right? So suppose initially you were sitting on the first bench over here. Then you saw that now the class teacher is going to go and you go to the last bench, which is suppose the sixth bench over here. So you have changed your place. You have changed your position. Your initial position was here. This is I, initial position. And final position was this, that is F. So displacement is nothing, but it is the shortest distance between the initial position and the final position. So this distance, that this shortest distance between the initial and the final position is your displacement. Got it? And displacement is always from initial to final. It is from initial to final. So it is having direction, right? It has direction and it has magnitude also. Suppose the displacement which you have made is suppose it is suppose 10 meter, right? It is suppose 10 meter. So your displacement magnitude is 10 meter and direction is from first bench to the last bench to the sixth bench, right? So displacement is defined as the shortest distance between the initial and the final position of an object. For example, children, you went from first bench to last bench. Suppose this is your, let me draw it again. This is your first bench and this is your sixth bench, or let me write it last bench, right, beta? But you did not go straight. You first went in this row, you talked to a friend over here, then you went to that row, you talked to the friend here, then you talked over here, then you came back here, and then finally you are going to the last bench over here, right? This is your path, right? If suppose this is 2, this is 1, this is 2, and this is suppose it is 3, right? So if we calculate this total distance, total path length, the total path length will be 2 plus 1 plus 2 plus 3, right? That is 8. That 8 is this. What is your displacement? So your displacement is going to be the shortest distance between the initial and final. So this black line is your displacement. That is initial and final position के बीच में जो shortest distance होता है, जो straight distance होता है, that is displacement. So that displacement, that is your displacement. Getting? Okay. So displacement does not depend upon path. वो रास्ते पे depend नहीं करता है. That is only the shortest distance, right? So how you can define displacement? Displacement is the shortest distance between the initial and the final position of an object. And as it requires direction, that is from initial position to final position, it is a vector quantity. Its SI unit, it is measured in meters only, just like distance. Right, let's have an example over here. Okay, here, suppose an insect, the insect is moving from point A to B, B to C, A to A, sorry, O to A to B, and B to C. This is the path of the insect, right? Here, Initial position is O. Final position is C. So the shortest distance, as it is moving on a straight path, yahi hai shortest distance, right? The shortest distance is 5 plus 6 plus 7, right? Okay. Okay, now we are going to name the device which is used to measure the distance covered by an object. Children, if you look at the speedometer of your Activa, of the bike or of the car, what you will see? On that, you are having here, if it is an analog one, here one needle is there. Here you are having one needle, and here some numbers are written 10, 20, 30. These numbers, they indicate the speed, right? 60 kilometers per hour, 70 kilometers per hour, 80 kilometers per hour. And below this, you will see a rectangle. And in the rectangle, some numbers are written. And when you start your Activa, you will see that the last block, which is at one's place, there the number keeps on changing from 1 to 2, 2 to 3, 4, 5, 6, 7, 8, 9. And whatever number is in front, then it will change and it will become 80. Then from 80, the last digit will change. 1, 2, 3, 4, 5, 6, 7, 8, 9. 89, then it will become 90. So when you're moving the Activa, this is changing. So what does this device record? So this device is measuring the total distance covered by your scooty, the total distance covered by the vehicle. So odometer is the name of the device which is used to measure the distance covered by a device, right beta? Now let's try to understand distance and displacement a little more. So we will try solving a numerical. Let's read the question of the numerical. A particle is moving in a circular path with of radius r. So this is a circle of radius r. So circumference कितना हो जाएगा? R plus r, 2r, right beta? Now, what would be the distance? आपको distance find करना है, and displacement for two cases. First one, for half a circle means जब particle ने आधा circle complete किया है, you have to find distance and displacement. When particle has covered the complete circle, you have to find the distance and displacement. So let's start with the first one, that is when particle has covered the half circle. Half circle means if the particle has started from point A, at point B, half circle will be done, beta, right? So from A to B, half circle. Now let's find the distance. So path कौन सा है इसका बेटा? Path है इसका circle, but आधा circle. So पूरा circle होता तो circumference of circle होता, that is 2 pi r. But this is half circle. So the distance is half into circumference of circle, that is circumference का आधा, because the particle has moved only half of the circle, right? So half of 2 pi r, 2 cancel, your distance covered is pi r. This is the distance covered when the particle has traveled half a circle, right? Now let's see the displacement. So when the particle started from point A and stops at point B, so initial position is A, final position is B. So displacement is the shortest distance between initial and final position, right beta? So the shortest distance between the initial and final position is AB, that is along the diameter. So displacement क्या हो जाएगा बेटा? Displacement will be AB, that is R plus R, that is 2R. So 2R is the displacement, 2R is the distance between the initial position A and final position B, that is R plus R, 2R. Okay, chalo. Now let's calculate the distance and displacement for complete circle. When the particle has completed the circle. So when the particle has completed circle means the particle has started from point A and it has covered the full circle and it has again come back to A. Right. So the particle has covered, or the particle has traveled the path, that is total circumference. So we know the distance is the path. So it is the circumference of the circle, that is 2 pi r. But what about the displacement? Initial position is A. Final position is also A. So shortest distance between A and A, same point pe hai, is 0. So the displacement in this case is 0, because the initial position and the final position is same. That is your point A. Okay. So children, distance is the total path length covered by an object or traveled by an object, and it is a scalar quantity. But displacement is the shortest distance between the initial position and final position of an object, and it is a vector quantity. Okay, beta? Fine.